few minutes to introduce Erin, our speaker for this evening. Erin is the Technical Service Manager for STERIS Corporation. Since 2015, he's been responsible for providing global technical support, primarily for critical environments, i.e. environmental sanitizers, disinfectants, sporicides, sterility assurance products, and barrier product solutions, application and validation. For over 20 years, specializing in cleaning, disinfection, sterilization, and contamination control in parenteral drug manufacturing, Erin has gained experience interfacing with industry regulatory agencies representing quality assurance programs. He's a member of various industry organizations, including PDA and ISPE, since 1999, presenting posters and talks, and is current president of the ISPE Great Britain Chapter. He holds a bachelor's degree in genetics from the University of Wisconsin-Madison. He will be presenting for the next hour or so, and I'll just let him put up his slides now. And we will have questions, time for questions for about 30 minutes after he presents. So please do post your questions on the chat. And also, please feel welcome to unmute and ask your questions directly. So without further ado, I'll hand over to Erin, and over to you.
Great. Thank you very much, Linda, and thanks, Christina, for having me today. I really appreciate the partnership with ISPE Singapore. There's been so many great events. I've presented in the past in November talking about steam sterilization, microbiology, and performance qualification. And following that webinar, I did have many great interactions with attendees, different discussions, questions. So I really appreciate that partnership and opportunity to present again today. So thank you very much to ISPE Singapore and Linda and Christina. Also, just a quick thank you to my colleagues in Singapore, Richard Chai, who's a technical services manager there locally for Singapore, and also my colleague Neo, who's the STERIS sales director. And then lastly, the sponsors. Thank you for allowing these webinars to be presented to everyone for free. It's really a great way to network and provide some technical content to your chapter. So with that being said, welcome everyone, good evening, thanks for joining. As Linda said, my name is Aaron Mertens. I'm a technical services manager and a microbiologist for STERIS Life Sciences. Here on the screen is my contact information. Please feel free to reach out to me. Probably by email is easiest. I'd love to hear questions that might come up after the webinar. If you're uncomfortable with speaking up this evening, or if you think of questions later on, please feel free to go ahead and give me an email. So that being said, the outline for this evening is as follows. We will be talking about parts preparation for autoclave steam sterilization, and really the methods, the procedures to minimize variation and improve operational efficiency in that process. We'll talk through different sterilization wrapping materials and some criteria for selecting what's right for your process. And the second half then will be strategies for improving efficiency and quality post-steam sterilization. So this is really maintaining sterility of these critical parts and components during the transport and storage through your clean room. And then ultimately, ensuring that aseptic presentation at the time of use, installation of these parts on the filling line is done without compromising those critical surfaces. And then lastly, we'll talk over different considerations for vaporized hydrogen peroxide, the VHP decontamination in the filling environment, whether it's in a restricted access barrier system or an isolator. This content, I would say, probably will be finished in about an hour. And then since we scheduled an hour and a half for this talk, we'll have plenty of time for questions at the end. But as Linda said, please feel free to enter any questions you might have into the web chat, and we can handle those in real time as well. Okay, to start things off, why are we wrapping parts and components? What's the purpose of this? So really, sterilization wrapping is protection. We're protecting critical surfaces, parts, after cleaning and preparation prior to the sterilization process. And then post-sterilization, the sterilization wrapping is intended to maintain sterility during transport and storage in your clean room prior to use. And of course, it's not just efficiency and ease wrapping your parts, but really we need to think about at the time of use, how these parts were wrapped and prepared in order to facilitate aseptic technique during line setup and use of the components. So just to back up real quick, the scope here is autoclave sterilization specifically for what I call in-process sterilization. So these are filling components, filling pumps, stopper bowls, product contact surfaces primarily used in parenteral drug manufacturers. So this is aseptic processing rather than terminal sterilization of a finished drug product or a medical device. So I call this in-process sterilization, where we're using aseptic filling operations of parenterals. So of course, maintaining those critical surfaces as sterile is absolutely paramount. In order to make this happen, we really need to have well-defined procedures. And of course, these procedures are supported by validation. In the last webinar, if you were able to join, we talked about the autoclave process validation itself, but really the focus of regulation has moved beyond the scope of just autoclave or sterilization validation. The scope has changed to include the parts preparation, so that's using the sterilization wrapping, all the way through the transport, storage, and unwrapping. So the procedures that we're writing up for sterilization wrapping or parts preparation needs to be well defined and validated. And of course, with any procedures, operators need to have adequate training, so a thorough training plan, including recurring training. So we need to demonstrate proficiency, not just once, but periodically, typically an annual training or some sort of refresher. And with the autoclave sterilization validation, even the sterilization wrapping, the parts prep, and the component installation on the filling line, all of this, since it's validated, needs to be included in your change control process. So this includes which parts, components, materials are going through the sterilization process in the autoclave, also the wrapping materials, the material type itself, and the different converted materials, whether it's a sterilization pouch or a cover of some sort. All of these materials need to be defined in the validation, in the procedures, and then monitored closely for change control. Really, this is a holistic process. When we're establishing our wrapping procedures, the process has to include evaluation of different wrapping materials such that these materials promote consistency and minimize variability. So that's part of the change control process. If we have a process or procedures for preparing equipment for sterilization, it's under change control. If anything is altered in the wrapping materials or that process, could impact the validation, could impact the variability of that process. So here, just to keep things a little bit interesting, I have a video. It's a side-by-side comparison of different wrapping materials and techniques. And I think you'll see a pretty obvious difference in the materials, which allow for that consistency and efficiency. So let's start that up, see what it looks like here. The materials used here, the blue material is a cellulose or paper-based sterilization wrapping. I would say this is a legacy material, and the woman there is using tape and large sheets of the blue paper. And the other material is a polyolefin or Tyvek material, and these operators applied an elastic cover over the stopper bowl, and now they're placing it in a polyolefin bag with a drawstring. And you can see that white polyolefin material allows for easy implementation of the sterilization wrapping. It's double protected. That primary product contact surface is covered first by the elasticized cover and then into the drawstring bag. Whereas that blue paper, you can see perhaps there were many layers of the blue paper because of the way it's wrapped with those sheets. And this was a real case study that STERIS used with an end user. And I did a little Q&A with that operator with the blue paper, and I said, wow, do you always use that amount of tape with the blue paper? And she said, absolutely, because sometimes if that much tape is not used, the wrapping can open during the sterilization process through the autoclave. So she even indicated that other operators might not use that amount of tape, and therefore there can be issues with integrity through the autoclave process. So you can see not only the possibility for reproducibility with the polyolefin materials, consistency from operator to operator is definitely enhanced, a better process with the polyolefin material. But if you look at the clock there, it took just under a minute for those two operators to prepare the large, bulky, cumbersome stopper bowl for sterilization compared to nearly 6 minutes with the blue paper wrapping. So that's just an introduction, a highlight of what we'll dive more deeply into for the next 45 minutes or so. So just to back things up a little bit, I'd like to discuss different sterilization wrapping materials. So these are the products themselves and the attributes of these materials and some criteria that I encourage you to use when selecting wrapping materials for a new sterilization process, or perhaps taking a look at your current practices and evaluating if some improvements can be made. So first off, I would say the highlights, the most important attributes here of the materials have to do with how they interact in the sterilization process through the autoclave sterilization. So does the material have good steam penetrability? Can sterilization take place through these wrapping materials? Likewise, are the materials breathable? Do they allow for moisture aeration during the drying in the autoclave? As you probably know, it's important once the materials are sterilized that they also must be dry to prevent recontamination after removal from the autoclave. So during transport and storage, after the parts are sterile, we have to have a material that is a good microbial barrier. So this is maintaining sterility of the critical surfaces. So a material that blocks microorganisms from contaminating the sterile parts, also blocking any particulate contamination that might potentially happen in the clean room. Not only is it important that the sterilization wrapping protects the parts and equipment within the bag or the wrap itself, but also the wrapping material cannot contribute or contaminate the environment that it's used in. So the material has to be clean. There has to be minimal or no possibility for particle or fiber generation. Of course, there needs to be temperature tolerance. So the material has to be able to go through an autoclave process. So certainly has to be tolerant of temperatures up to 125 or 127 degrees Celsius of steam. Also, it has to be tolerant of clean room conditions. So there's defined relative humidity and temperature conditions in your clean room, and the material needs to maintain these critical attributes while being used in the clean room. So the next bullet point here is ease of use. I think that our video we just saw demonstrates the advantages of different types of materials during preparation. So that's just one half of the equation. How easy is the material during the wrapping, during the preparation before sterilization? And later on, we'll talk about ease of use at the filling line, the aseptic presentation, the unwrapping of the sterile parts. I have another video towards the end of the presentation that'll highlight that aseptic presentation. Last point here is ensuring that the sterilization wrapping material is compatible with any disinfectants or sporicides that might be used to decontaminate the surface of the sterilization wrapping as it's moving through your cleanroom facility. For example, if your autoclave is emptying out into an ISO 6 grade clean room and the storage room is an ISO 6 class, perhaps the filling line is in an ISO 5 grade clean room, that transition from the ISO 6 to the ISO 5 needs to have a surface decontamination done to the sterilization wrapping. Typically, this is done with a sporicide application, a spray or a wipe down. So we need to ensure that the sterilization wrapping is compatible with your decontamination chemistry, your sporicide. And then lastly, if the wrapped materials will be staged on the filling line. Typically, the filling line is then decontaminated using vaporized hydrogen peroxide or VHP. We need to ensure that the materials used are compatible with VHP as well. So now more specifics about the wrapping material itself. There are many different attributes possible with the different materials. This is customizable, I would say. It needs to be evaluated in the way that your process looks. So is a fabric-like or drapable wrapping material preferred, or maybe a more rigid material is preferred, so the flexibility of the material is evaluated. How durable is the material, both during preparation and during setup at the line? Certainly, its primary feature is maintaining sterility, so we have to ensure that the material is puncture resistant, that it has an appropriate tear strength. For some processes, it's an advantage to have a transparent sterilization wrapping, so you're able to view the contents of the bag. There are different sterilization pouches that are a combination polyolefin and maybe a polyethylene film. So that film layer allows for viewing the contents of the bag. Depending on the type of wrapping that's used, there are a number of different methods for closure of the wrap. So you saw in the video there, the blue cellulose paper was needed to have tape to ensure the closure, versus the white polyolefin had an elasticized cover and then a drawstring bag. So a lot of different options, methods of closure. I think you'll see at the end of the presentation here that the method of closure really needs to be evaluated for how the equipment will be unwrapped. That's really the most important part. How easy is that closure to open up? You can imagine peeling all that tape off of the paper can create a particle hazard for your critical surfaces during the unwrapping of the components. And lastly, the strength of closure. This is most important, that the closure method maintains integrity through the sterilization process in the autoclave. So those are the attributes, the things we need to think about when we're evaluating different sterilization wrapping materials. Now I'll just go over some highlight material types and some of the advantages, disadvantages. And really, this is an overview. I'll focus more on what I call the legacy wrapping material, which is cellulose or paper, that blue paper. I think the industry is moving away from that to some of these alternative materials like the polyolefin. So I'll dive more deeply into the comparison between paper and the polyolefin, but I wanted to give you an overview of all the different options here. So you saw the blue paper, the cellulose. These can be in sheets or what I call wrappers. They can also be converted into pouches, the paper and film style sterilization pouch. Likewise, there's the blue paper, there's also like a craft paper, we call it. So there's a few different options there. Wrappers and covers with the blue wrap. And then this polyolefin, it's called Spunbonded Polyolefin. Primarily, this is a material supplied by one manufacturer, DuPont, and the trade name for this is Tyvek. So this material is a little more flexible in regards to the type of sterilization wrapping that the Tyvek can be converted to. So it's available in the same type of sheets, these wrappers that come in pre-cut size sheets, but also, as you saw, there's the possibility to have elastic into these Tyvek sheets, creating a bowl cover. Also, these can be converted into the pouches, which is a Tyvek layer in the film, different bags with drawstrings, for example, and certainly all different size covers. Lots of options there. I'll show some photos here in the next coming slides. Those are really the primary options, different types of paper compared to different types of the polyolefin. I just wanted to point out there are some others out there on the market, something called SMS, which is a 3-layer laminated polypropylene. SMS stands for spun-bonded, melt-blown, spun-bonded polypropylene. This is, I would say, more comparable to the polyolefin or the Tyvek, so it has some good properties, but I would say there are some limitations to the SMS as well. Other options include polyester bags. These are reusable. Sometimes they have zippers or snaps for closures. Again, these are less prevalent in the industry, and I'll talk through why maybe these are not the best options for sterilization for the in-process parts and components. Let's start first with some overview advantages and disadvantages of the cellulose or paper. This first slide here with the comparison is talking about the rigid craft paper that's used in creating the combination film and paper pouches. I have here up in the corner, a scanning electron microscope image, And you can see that this craft paper has a fairly dense look to it. All of these fibers look to be fairly tightly woven, and it seems to be like it would make a good filter and a good microbial barrier. And that's true, it does provide a microbial barrier, but all of those fibers that you can see in that image, those fibers can become loose. Certainly when the material is wet, the material does not hold its strength, and those fibers can be released as possible contaminants. But even so, the paper does have some advantages. This material's been used for sterilization wrapping for decades. It does allow good steam penetration. The aeration properties in the autoclave are good. The parts can be dried quite easily in the autoclave when wrapped with paper. The microbial barrier is also good, however, only when intact. So paper can be torn, especially during the sterilization process. It becomes saturated or wet, and we can have tearing through that process. It does become weak. Advantages also, paper is compatible with a wide temperature range, certainly higher than our sterilization temperature we typically use. So no problems there. There's the advantage that it can be combined with the film layer for the pouches mentioned. And certainly the biggest advantage is the historical perspective. We know about this material, there's data about the material through the sterilization process, and it is the least expensive option. However, the list of disadvantages here, we've talked through a lot of this. It is a material that becomes saturated during the sterilization process, and therefore it has to be dried during the autoclave process. During the wetting and drying, it becomes brittle, can easily be damaged and torn, and this is compromising the microbial barrier. As I mentioned, it does generate particles. So not only does the material itself release particles and fibers, but it's not necessarily a clean material. So there's not really an option or a way to ensure that the material itself is clean. So the paper can release particles, but it also holds particles on the surface. So it's not very robust, easy to tear or puncture, requires a separate closure method. So there's not an option for a integrated drawstring like we saw with the Tyvek bag. And then the pouch sizes are limited. So we do have a pretty good list of disadvantages. I would say the focus right now, the move away from paper, is specifically having to do with the particle generation and the microbial barrier. So when we talk more about the other options, the polyolefin options, we'll see a comparison between cellulose or paper and the polyolefin or Tyvek. So here's another type of paper, the blue wrap, which we saw before. Again, a scanning electron microscope image looks very similar to the craft paper on the previous slide. Again, you can see the fibers have a pretty tight format there, which does in fact block microorganisms when intact. So the advantages, very similar to the previous slide, with good steam penetration and drying. It is an effective microbial barrier when intact, compatible with a wide temperature range through the sterilization process. And the blue paper here, as you saw in the video, is fabric-like. It is drapable, so it can take the form of the big bulky parts or equipment that will be wrapped. So it does have an advantage there that it is not rigid, but rather fabric-like. And the blue paper, we've seen that it is a little more rugged than the craft paper as well. Really the same disadvantages. I won't belabor the point here. The barrier integrity depends upon the wrapping method. So if you look at the way that stopper bowl was wrapped, there were some gaps around the tape there. And certainly if there are gaps, you have possibility of contamination. The particle generation issue, again with this, same as the craft paper. And then lastly here, down the list, this one has a limitation. It cannot be heat sealed, cannot have a drawstring. Really the only option is to use tape for the closure method. Okay, so that's in comparison to these polyolefin or Tyvek options. Again, I have the scanning electron microscope image there. If you recall, the fibrous look of the paper is certainly different than the look in the image here of the polyolefin. So rather than a fibrous network, the polyolefin has a much different structure. So this is a non-woven material. So this is bonded rather than woven like a paper. So the microbial barrier properties, really it's a tighter filter blocking out microorganisms or particles than the paper. Even so, we have better steam penetration and drying properties with the polyolefin material. I have some data later on to show using an ASTM method, the microbial challenge, the difference between the two types of paper and a few different types of polyolefin material. I like to point out here that the polyolefin does not absorb water. It's a hydrophobic material. So during the drying portion of your sterilization cycle, there's not the challenge of trying to dry the sterilization wrapping material itself along with the parts contained within. The hydrophobic nature really allows for fast, easy steam penetration and then fast, easy drying at the end of the cycle. The polyolefin material does not generate particulate itself. So the normal wrapping and unwrapping process does not release any particles or fibers from the Tyvek material. It's fabric-like and drapable, as you saw in the video, very resistant to tearing and puncture. Even in the sterilization process, it's hydrophobic, so it doesn't absorb moisture or become brittle or easily torn or punctured like the paper. This material can be converted into bags, tubings, covers, pouches, etc. A few more advantages, we could go on and on. If the Tyvek is formed into a combination film pouch, again, the visibility, the viewing of the parts contained within. These pouches can be heat sealed, so you have a very good integral seal through a heat seal process. And these different materials are able to be manufactured in a clean room environment. So not only do they not shed particulates during the use, they also would have very low number of particles on the surface. So it's a clean material. This allows for not just the protection of the parts within, but the clean surface will not become a contamination source in your environment. So a couple disadvantages I have to point out. We do have a limited temperature range since it is a poly material. The maximum through a steam sterilization process is 127 degrees Celsius temperature. And of course, this one is a more expensive option than the paper. Now, I have to say that cost is often a focus, but really compared to the advantages, the sterility assurance advantages, any regulator will not allow a lesser material to be used because of cost. So we have to think about the overall cost, not just the dollar amount, but also the cost of compliance and the cost of sterility assurance. So regardless of the type of sterilization wrapping material, when these materials are converted to different bags or pouches or covers, there are different closure methods as well. So you saw in the video before use of autoclave tape. This, of course, I would say is the legacy way to close sterilization wrapping. Again, it's an inexpensive, cheap, readily available tool. However, there is the same concern with particle generation, especially when opening up at the time of use. You're tearing away the tape, particles can be released. The last bullet point here under disadvantages, it's not a very reproducible or repeatable method of closure as well. So remember, the wrapping process itself is part of the validation, and this needs to be consistent and reproducible. Clearly, you can see from the video that not each operator would be wrapping with the same methods. The next one here are strings or ties. These could be loose, not integrated into the bag itself. I would say that the preferred method is to have an integrated drawstring. There's a closure method which we call the gooseneck closure, which provides a tortuous path. So this is basically a way to secure a bag with an integrated drawstring, not allowing for any microbial ingress. So really, that's what we're going to focus on, is probably the difference of using tape with different cellulose materials compared to strings or ties, drawstrings. I think the polyolefin lends itself to the strings or ties versus the cellulose material typically uses tape. Down here at the bottom, the heat seal or the self-seal, typically these are closure methods when we have an integrated pouch, the combination Tyvek and film compared to the paper and film pouch. So these are either closed with a separate tool equipment called a heat sealer, or some of these pouches have what we call a self-seal option, where the adhesive is directly integrated on the pouch. So of course, advantages and disadvantages to these different options for the pouch closure. The heat sealer is nice because it is a separate piece of equipment. It has operating parameters that can be locked down as part of the validation. This is the highest level of seal integrity, repeatable, very clean, easy. However, it is another piece of equipment to maintain. Validation is necessary, might be an added expense. The self-seal pouch also has very good seal integrity. It's a repeatable process for the operator, so there's very specific process that is repeatable. And the opening during the time of use of these self-seal pouches is also very repeatable. These pouches typically have easy unwrapping, what's called a chevron peel, where the pouch can be opened easily by the operator without any extra tools, cutting tools and the like. And this process does not even generate particles as well. So just to pause here, maybe there are some questions. We're about, I guess, halfway through the slides and covered a lot of material so far. We'll see if we have any questions. Okay, nothing so far. So you might be asking yourself, all of these different options, all of the attributes for the different materials, that's a lot to think about. How do we go about selecting the right materials, the right sterilization wrapping for our process? Well, my recommendation, the first bullet point here, is to understand your process from the start to finish. Don't have one team evaluate the wrapping process and then a different team talk about the sterilization in the autoclave, and then a different team thinking about how to unwrap and use these parts at the filling line. All of the players from start to finish should be at the table to discuss the advantages through the entire process. The people who are wrapping, preparing equipment for sterilization might not be the same people who are unwrapping at the time of use. So these folks should be talking to each other to make sure that the way the equipment is prepared facilitates the way the equipment will be used at the end. So know your process from start to finish. Understand the sterilization validation criteria. So I mentioned that sterilization validation is a scope that is very much scrutinized by regulations, but I would say that scope has expanded in recent years. Sterilization validation is not just the autoclave process, but the preparation of the parts and the aseptic presentation at the time of use. So the scope has widened, and regulators are auditing based on this wider scope of sterilization validation. So be aware of this. It's not just the autoclaving itself, but preparation through the time of use. And I can't mention this one enough, because wrapping and unwrapping now is part of the validation. The process should be efficient and reproducible, regardless of which operator is performing the wrapping and unwrapping. So in the autoclave, certainly the way the parts are wrapped and positioned on the autoclave cart or within the equipment, this should be done such that the equipment will not hold condensation. Likewise, the wrapping material should not block condensation draining. And lastly, I mentioned this already, prepare the items in a way that will promote aseptic presentation. So really, this is the holistic view of selecting the sterilization wrapping. It really needs to be done holistically in order to have the best process from start to finish. Know the regulations as well. So this is a reference from the draft EU Annex 1. So this is a new regulation or a revised regulation that should be coming out later this year. Section 4.7 specifically states materials used in clean rooms should be selected to minimize generation of particles. So remember that cellulose materials, we know, generate particles. So I would say this is especially critical for product contact parts and surfaces. Annex 1, Section 8.9 repeats this and says the presence of materials liable to generate particles and fibers should be minimized in clean rooms. So this is certainly going to be a focus during audits, especially for materials manufactured in Europe or sold into the European market. So take a look at all of the different parts and equipment that you're sterilizing. These large bulky parts like stopper hoppers or stopper bowls certainly can be a challenge. Large trays might lend themselves to different sterilization wrapping materials. And certainly, likewise, very small, intricate parts require special attention and different types of wrapping materials than those large parts. Here's one that's often overlooked. This is a photo of a mop bucket used for cleaning and disinfection of the clean room environment itself. These cleaning implements, like the mop buckets, need to be entered into the clean room through the autoclave. Typically, they can't create contamination hazard in the clean room. So you can imagine these large buckets are cumbersome, hard to wrap, much like the stopper bowl in the video. So think about wrapping solutions that create a more efficient and effective wrapping process and unwrapping process in the clean room. So here you can see elasticized cover in the middle photo. But also these cleaning and disinfection tools and parts, they occupy a large volume within the autoclave, and they need to go into the clean room frequently, perhaps on a daily basis. So maybe there's a way to minimize the number of sterilization treatments for these mop buckets by using a sterile mop bucket liner. So this, again, has been reviewed by regulations and found to be acceptable, that these cleaning and disinfection tools like the mop bucket could be entered into the clean room through the autoclave on a weekly basis, for example, provided that a sterile mop bucket liner is used, a new mop bucket liner is used each day for the cleaning and disinfection. So that's a way to enter this equipment in through the autoclave less frequently, opening up capacity for the autoclave for other more critical parts and equipment. So as promised, we'll get more into the details with some data comparing paper or cellulose versus Tyvek or the polyolefin. This here is the legacy process, a couple photos of how these paper sheets are used to wrap up equipment or parts like a package using tape. Also a photo there of the combination film and paper pouches. Again, I think that we're at risk here using these cellulose materials compared to the polyolefin materials. And again, I think the advantages of the polyolefin are for the very large parts and also the very small parts. And I like to recommend having 2 layers of protection for the product contact surfaces. Like a filling needle here has a small drawstring bag as the primary protection. Likewise, the stopper bowl here has an elasticized cover as the primary protection. And then both of these items can be placed into a larger bag for the secondary protection. So at the time of equipment wrapping or preparation, the advantages might not be seen. However, at the time of use, unwrapping the parts from the overwrap with the primary product contact surface still protected really lends itself to the best aseptic technique. So from a sterility assurance standpoint, the microbial barrier needs to be compared between paper and polyolefin. Particle generation needs to be compared. The idea of double wrapping and compatibility with sanitizers, disinfectants, and sporicides. So I would say from a sterility assurance standpoint, these are the attributes that are most compelling when comparing paper and polyolefin. So what we did at STERIS is took a look at the differences of the materials in a few different simulation studies. These are in-use simulations. This one here, we simply peeled open different pouches of different materials. We peeled these pouches open in a controlled ISO 5 class hood. All the time we were monitoring the air quality, so we were collecting particle counts in the ISO 5 hood and enumerating particles of 0.5 and 5 microns in size. We did this with a few different size pouches and different types of material contained within the pouches, but primarily we were comparing paper-based pouches with the polyolefin pouches. And we saw that the polyolefin pouch on average generates less than 1/10 the number of particles, 0.5 and 5 microns in size, compared to the cellulose pouch. So this is really quite compelling to use the polyolefin pouch to protect the clean room environment. So likewise, we compared the flexible paper versus the flexible polyolefin. Here we have that large, bulky, cumbersome stopper bowl, and we chose an elasticized cover and a drawstring bag made from polyolefin compared to the blue paper and tape shown here. So during the simulation, we wrapped the items with the different wrapping materials. We measured the particles 0.5 and 5 microns during that process. And we also timed how long the process took. So as shown in the video previously, the timing, the efficiency was much better with the white polyolefin compared to the blue paper. But certainly we had a magnitude difference in particles generated when using the paper and tape. So it was at least twofold in every case, more particles with the cellulose compared to the polyolefin. So the difference was quite a bit more with the very large materials parts and the very small parts. The difference was much more noticeable. We also ran these parts through a sterilization cycle in the autoclave and then measured particles generated during the unwrapping and the time required to unwrap the materials. And again, we saw a minimum twofold difference in particles generated. So that was the particle difference. And I also mentioned earlier that there was a difference in microbial barrier properties. So here we did tests using a standardized ASTM method. This is for microbial ranking of porous packing materials. This ASTM challenge is using airborne bacteria, Bacillus atrophius spores, in an aerosol form to measure the passage of bacteria through the material. It's really a filtration efficiency test. So we tested the rigid polyolefin, a flexible polyolefin, the blue cellulose wrap, and then the rigid craft paper wrap. On one side of the material, we challenged with approximately 10 to the 7th bacterial spores, and we collected the amount of spores, of the amount of bacteria on the other side of the material, and calculated a log reduction value. So really a filtration efficiency through the material itself. And for the polyolefin or Tyvek material, we saw over a 4 log reduction versus the paper had a 2 log reduction. So in summary here, the test results indicated that the polyolefin materials prevent passage of greater than the 4 log microorganism population, which calculates to greater than a 99.99% spore retention effectiveness. So to move on here, that data is pretty compelling, but what about maintaining sterility and transport during storage? So when we're unloading the autoclave, we need to confirm that we had a sterilization cycle that was successful. We're reviewing the cycle for alarms, checking that there are no deviations in the cycle, confirming the results of any chemical or biological indicators used. This is the first part to ensure we have a successful sterilization process. We're also checking that the load configuration is according to the validation as documented in our procedures. We're checking for dryness of the load, no pooled condensation inside or on the surface of the sterilization wrapping, and also checking the integrity of the sterilization wrapping itself. There's an option here to have a secondary protection of the sterilized parts. We call this a sterility maintenance bag. This is a 100% poly bag, which is 100% impermeable, complete microbial barrier. This is an option for transport and storage where we're placing materials directly from the autoclave into this sterility maintenance bag, typically in an ISO 5 area. This secondary protection is perfect if these items are passed through a lower classified area during transport. The surface can be sanitized in the material handling airlock. The sterility maintenance bag captures the environment during unload. So typically the autoclave unload is in an ISO 5 area. The bag would be sealed up, capturing that ISO 5 area. If the materials are then transferred through maybe an ISO 6 or an ISO 8 area, the sterile parts inside would not be exposed to that lesser classification. As I mentioned, this is impervious, really reduces the risk of contamination, and facilitates aggressive and effective surface sanitization. So this poly material is impenetrable to the chemical disinfectants. And this is not considered part of the validation like the sterilization wrapping, so it could be implemented without impacting the validation. It provides an extra layer of protection without impacting change control. I've seen out there different options to protect equipment, sterile equipment, through different classes in your clean room facility, like a HEPA filter cart. This is a great option, but it is a very expensive option. Therefore, this sterility maintenance bag could be implemented much more economically. So that was the transport using the sterility maintenance bag. The same type of advantages apply to the storage. So placing the equipment into the sterility maintenance bag in the ISO 5 class clean room. Storage could be in a lower class. Again, the surface is protected from the lower class environment. Then moving that wrapped package to the higher class simply requires a surface sanitization through the material handling airlock. So this really can extend the storage of the sterile materials from hours to days or weeks. So the storage time can really be extended if you have this secondary protection. The same attributes here. It provides an impervious layer of protection, reduces risk of contamination, facilitates aggressive use of surface decontamination methods, and can be incorporated with minimal qualification or validation. So here's a little closer look at what those sterility maintenance bags look like. Again, I mentioned it's a 100% poly plastic bag here. It does have a self-seal adhesive closure, so there's a protective strip there that's removed, exposing the adhesive, and then that's folded over to seal the bag. Medical grade film that is puncture resistant. And then there's what we call an easy tear open to open the bag there. It's easily peeled open, no tools required. So that's an option during transport and storage for an extra layer of protection. So as promised, here's another video. This one is on a conventional aseptic processing line. This is not a RABS or an isolator, but you can imagine the line setup, the installation of this part would be done on a RABS or isolator through an open door. So the operators will, in the video here, unwrap and install the stopper bowl quite easily on a conventional filling line, but this operation would be done through an open door for the RABS or isolator. So this is the drawstring bag made from the polyolefin material, easily removed. The elasticized cover is left on the stopper bowl while it's being installed on the filling line. And then immediately prior to use, that cover would be aseptically removed. So the big difference there with the conventional filling line and the RABS or isolator, the bowl would be removed and then the door would be closed with the stopper bowl in place with the elasticized cover still in place. Then the decontamination of the RABS or isolator would occur, doors closed, elasticized cover in place. Once the VHP decon was done, then the operator through glove ports would do the removal of the elasticized cover. The blue paper and tape compared to the elasticized bowl cover and drawstring bag. Likewise, the process is much more efficient and easy for these small intricate parts like the filling needle and associated tubing here. And there it is in its finished form. And then at the time of use, those tubing assemblies would be installed on the line in place. So those needles are still in the polyolefin drawstring bags there. The RABS or isolator doors would be closed, VHP decontamination complete, and then through the glove ports, those drawstring bags would be removed. So in more depth here, I mentioned a couple times for the RABS or isolator, we have the VHP decontamination process. Again, this is a focus of regulators nowadays, taking a look at the VHP decon process validation, but also the implementation of the different parts, the assembly of the line. When are these critical parts exposed? So I took a look at the regulations again here. The FDA in the United States, through the Code of Federal Regulations and Guidance for Industry, specifically states direct and indirect product contact surfaces must be sterilized. No problem, that's our autoclave validation. However, it also adds that items entering into an isolator must be decontaminated. Well, that's either through surface decontamination of the sterilization wrapping using a wipe down or a spray, but more typically the vaporized hydrogen peroxide process. That can be difficult, however, because the fluid path or product contact surfaces, like the filling needles and tubing and the stopper bowls, these must remain free from contaminants. Now, the surface disinfectants are in fact contaminants if they contact these critical product contact surfaces. Likewise, the VHP can be considered a contaminant. Therefore, we need to think about how to install these parts on the filling line without contaminating these critical surfaces. I'll mention draft Annex 1 again. This one's coming from the MHRA, which is in the United Kingdom. These guys are also talking very specifically about sterilization of critical surfaces, and maintaining these surfaces free of contamination. They get a little more explicit, saying disinfection of the exterior of the sealed packaging must occur. This can be done with a decontamination chemistry, a sporicide, or with vaporized hydrogen peroxide, or double wrapping multiple layers to allow removal of a single layer at each interface, parts moving from lower classification to higher classification. So I would say that most companies are using vaporized hydrogen peroxide in a RABS and an isolator. A lot of different advantages here compared to the liquid disinfectant.
I'm sorry, we seem to have lost Aaron. I think he will be rejoining the call. Apologies, everyone. I think Aaron seems to have been disconnected. Only one question from Francesco so far. So please do all post your questions in the meantime.
Okay, I'm not sure, Linda, where I broke up, but I think I'll hit the high point here to close with the RABS and isolator disinfection, and then we can jump to our questions, if that's okay. Okay, so to close this out, really what I was discussing is the regulations and the focus on VHP, decontamination of the RABs and isolators, and really introduction of sterile parts, and the process of decontaminating the surface while protecting the critical surfaces. So I would say that regulations, the only way to meet the regulations are to stage the wrapped covered parts in the RABs or isolator enclosure prior to decontamination process. And then after the aeration of the VHP process, uncover these critical surfaces through the glove ports. So there are different options here, 1, 2, and 3, but I would say the best way to do this to meet international or global regulations is number 2. And that's what we talked through in the video demonstration as well. So I would say that the VHP, again, is part of the overall holistic view, the sterilization wrapping from start to finish. We also have to think about compatibility with the decontamination of the isolator during line setup as well. So in conclusion here, we talked through a lot. We talked about preparing the parts for steam sterilization and the different wrapping materials. We definitely focused on strategies for improving efficiency and quality post-steam sterilization, the aseptic presentation at the filling line, and then a few considerations of the decontamination of the RABs and isolator. So I really apologize that we had a little breakup there in the connection. Hopefully we didn't lose too much content, but at this time, I'd like to open it up to questions. We can either put those in the chat or verbalize the questions you might have.
Thank you, Aaron. So Francesco Costa has a question, which is, in which way are storaged these materials?
Okay, Francesca, thanks for the question. I believe it's probably storage. The question is storage of sterile materials. If it's not, please clarify. But typically, after sterilization in the autoclave, these materials could be stored in a controlled environment, typically an ISO 5 through ISO 6, stored really in laminar flow. They can remain provided the sterilization wrapping is integral, they can remain in the clean room for whichever time you have validated. The duration, storage duration should be validated, but as long as it's covered as part of your validation, it should be stored in the clean room for the validated amount of time.
Yeah, okay, so that's
Thank you.
yes. Trishit Kumar, do you have a question? Does anyone else have a question? We've also posted up a link to a feedback survey. If you could help us just to click on that, you can fill that in very quickly after the session. In the meantime, are there any other questions for Aaron? This is your opportunity to ask for any clarifications, or if
Linda, Simone here.
Hi, Simone.
Hello. So I'm just reading the question list. There is a note actually from Mark. It's a no question. Agree that cost is not an excuse. I agree as well, but sometimes I'm seeing that is not an excuse, but is a possibility. Well, sometimes I've seen using cheaper material instead of more performance material to wrapping goods to be sterilized. So we need to keep in mind that companies sometimes also need to verify the cash flow, so the money in and out, and sometimes there is some cutting cost, and sometimes can be this part of the process that can be affected for cost saving. That's all. Congrats to Aaron, this really interesting presentation.
Well, thank you for the feedback. I would say that if you're using cost as a decision maker for selection of sterilization wrapping, I think you better have a lot of data in place to show regulators that the materials you chose are adequate and don't compromise sterility assurance or create an issue in your clean room with contamination. So, the total cost of the process should be considered, including cost of compliance, the cost if there's a sterilization breach or a particle contamination event. It's not just the physical cost of the wrapping material, but the overall cost of the process. So certainly, it needs to be evaluated as part of the selection of your sterilization wrapping, but regulators probably won't allow that to be a deciding factor, the cost of
Of course,
itself.
of course. Yeah. Auditors want us company to show expenses for this for wrapping material and the things, but so I agree with you. So companies should have a bunch of data to show that the process is strong and enough strong to support sterilization capabilities.
Yeah, that's great feedback. Great feedback.
Yeah.
Well, I would encourage companies out there to talk to the sterilization wrapping supplier and see if they've done any analysis of cost of compliance versus cost of the material itself. They might be able to help with the assessment. So that's something to think about as well, is to reach out to the providers there.
Yeah.
Is there any other question? I believe Michelle might have posted a question earlier. We have a few minutes left if anyone wants to ask anything or comment. Otherwise, we will be sending a follow-up email with the link to the recording and the handout. And if you have any other questions, please do let us know. We can forward that on to Aaron and the team. Otherwise, I'll give you a last chance to put your questions. Else we will let Aaron get on with the rest of his day. It's 9:20 in the morning for you.
And yeah, I have a full day ahead of me while you all are finishing up.
Yeah, when everyone else is finished off their day. So with that, thank you very much for your time, Erin, for sharing your expertise with us this evening. And thank you all for joining and staying on late into the evening. Wish you a good one, and thanks again for joining us, and we look forward to seeing everyone again soon. So with that, I think we'll close off here, Erin.
Okay. Thanks, everyone. Have a good evening.
Good evening. Bye-bye, Linda.
Everyone.
Okay, thank you.
Bye, Christina. Bye-bye.
Bye, everyone. Take care.